guys, welcome back to QBT. Let's talk about Kirchoff's first law. There are two. We are doing one video for the first one and another video for the second one because they're important and you need to know how to do it properly. Okay, so Kirchoff's first law effectively states that the sum of the current that goes in is equal to the sum that goes out. It's pretty simple, but learning to apply it in a circuit model, depending on whether it's a series or parallel circuit, it can become quite complicated. So what I've done is a tutorial for you which explains how we're using Kirchoff's first law. Okay, so check it out and pay attention to what's going on.
Okay, so let's discuss Kirchoff's first law further. So the question says to state Kirchoff's first law and to find the unknown values in the circuit shown. So this is Kirchoff's first law, and it states that the sum of the current in to a circuit is equal to the sum of the current that leaves a circuit. Okay, and what it is effectively it's the law of conservation of charge applied to electrical circuits. So let's see how we can use our knowledge of this formula to figure out the unknown values in our circuit. We've got X, Y, and Z. Okay, so the first thing that we can understand here is the value for X, because the value that is leaving the cell rather, is 4.2 amps. Okay, and the value that is returning to the cell has to be the same as the one that is leaving, right? Current in has to be equal to current out according to Kirchoff's first law. So we can straight away say that X is 4.2 amps. Okay, that's step one. Now, because this is a parallel circuit, okay, and current is shared in a parallel circuit, we can see that it splits at the junctions, right? We've got two different junctions. We've got one here and we've got one here, right? And we can see that the current splits. And we need to find the value for Y, and we also need to find the value for Z. Well, okay, so if it starts off as 4.2 and it splits here, at this junction here, and 2.8 amps leave as it's travelling down, then the remaining current has to travel across through to Y. So at this junction, we would say that the current that is here is 4.2 minus 2.8, which would be 1.4. Okay, 1.4 amps. And then this 2.8 amps continues down and splits again here and here. Okay, so that 2.8 amps splits, and we have 1.2 amps here, and then we have an unknown value. So the difference is 2.8 minus 1.2, okay, which is 1.6. And that is how we use our knowledge of Kirchoff's first law to figure out how current is split in a circuit like this.
Okay, so hopefully that helped you understand how we can apply Kirchoff's first law in parallel circuits. Okay, very important skill, very valuable skill. It could set up a whole set of questions. Okay, so really make sure that you know these laws inside out. Okay, in the meantime, please like and subscribe. It really helps us grow the channel, and check out the videos that we've linked in the description below because they will help you understand this a bit better. But yeah, in the meantime, I'll see you next time, and remember to stay quantum. Okay, bye guys.